Hello, folks. Welcome to our Wednesday's co-working sessions, which are calls inside our Android devs community, which we are holding every Wednesday. And recently, we started going live on YouTube. So, if you are following us on YouTube, welcome. Um, to access, if you're only watching us on YouTube and you don't know about these calls that we are making every Wednesday, you can join our community. You can find links below this stream and you can join the community, and inside the community we make basically it's a collaborative space for Android developers, and then we collect topics that we are going to be covering in these Wednesday calls, other than the other things that we are actually doing there. Okay, hi Eric, how are you doing?
Hey Jov, I'm doing great. How about you?
Great, cool. I've just started the session, the stream. You're the first one in the call. So for the people on YouTube, we are having also a call on Meet while we are streaming on YouTube, so that we can have some more collaboration, basically. And for today, what we have as topics is basically this stream is gonna be tuning around testing on Android. So I would like to cover some topics around testing, um, and we'll be curious how that's gonna go. So let's give it maybe a little while, maybe like 2-3 minutes, and then we'll start with the topics. And as you can see on the stream on top, we have um, we have the agenda. And if we take a look at the agenda for today, we are having some stuff around testing on Android. We are going to start with the what are the tests that we have to that usually will find on Android projects, or what are at least the tests that I am writing. We are going to start from smaller pieces, then towards bigger. We are going to talk about integrated versus integration tests, which is a topic that is always, I mean, this is just terminology that is widely used inside software development communities about integration tests, which are not actually the tests that, I mean, integration tests are not the tests that usually people refer to, and we're going to talk about that. Then we are going to cover some topics that were asked inside the community when I was collecting topics about this stream, which is how would you start doing outside-in test-driven development on Android, or how would you start with the acceptance tests, given that we have to take in consideration some UI. Then we are going to take a look how would we approach testing in modularized setup. Basically, we're going to take a look into an example. And then we're going to talk about UI testing a little bit. There will be a bonus and there will be a place for Q&A. If you are following on YouTube, please drop your questions in a chat. Hopefully, I'll be able to answer those. Eric, since you're the only one on the call, do you have access to the stream on YouTube? And could you tell me if the sound is working okay?
Let me check it out.
Yeah. And then we can just start. By the way, for the folks on YouTube, it would be nice if you can press like and subscribe. That's gonna help the stream and the channel, but also it is going to be beneficial for you because you will get notifications whenever we publish something. Okay, so somebody said, Ivan Sanchez said it is working fine on YouTube, which is great. Thank you. So let's actually get started. So first things first, when it comes to testing just about any software, we start with testing something small, like smaller pieces of code. And that leads us to this topic that is often being, I wouldn't say like controversial, but people are arguing around what is a unit. So we are sort of testing smaller pieces of code, and usually we call these tests unit tests. But what actually is a unit? Um, is it a function? Shall we consider function a unit? Is that a piece of functionality that we can call a unit that we are trying to test, what if this function belongs to a class? And then would this class then be a unit? Or if this class is single class inside a module, let's say, would then the module be a unit? So what do we consider unit? Um, so rather than if we flip the game on the other side, if we don't think of sort of physical code as of unit, then what would define a unit? Um, in the software craftsmanship communities that I'm part of, we consider unit as piece of functionality or a behavior. So single behavior could exist in a function, in few functions, maybe in a class, but it is not attached to physical code. So it's not bound to a physical code. It is more about the behavior that we're trying to test. So maybe we're going to penetrate through a one public API, which is a function, let's say, but this function might call inside another functions. Maybe it's going to collaborate with another classes if it coexists in a class. And that would define a unit. Now, um, partly why this is being maybe conceptually people are thinking around it differently is that if we consider this unit to consist of behavior and behavior being part of like several pieces or blocks of code, then would that be a unit test or would that be an integration test, if like as it is widely known? So we are basically now moving towards a little bit bigger concept of a test that catches more around or covers more. And that sort of not misunderstanding but sort of terminology thing that is often how should I bring this, um, it is often, I shouldn't say it's misunderstood but misleading in communities around software development, is like integration tests. So people call integration tests the tests that are sort of covering bigger bigger blocks of code. So if you have like two or three classes collaborating together, and if you are trying to test that, people often refer to these tests that are exercising this piece of functionality as integration tests. Now, that is a misleading terminology, because integration tests are tests that are checking integration between different systems. When we are talking about software, which is, let's say, you're having few classes inside your domain, these are not different systems, they belong to the same system. And in that sense, these tests that are checking or covering bigger sort of function or bigger um, physical code, like several classes, they are referred to as integrated tests, not integration. So they are called either integrated tests, or we also call them sociable tests. And both of them actually are we can both of them consider as unit tests, because they are covering unit of functionality, not unit of code, of physical code, like not a function or a class as we started, but they are covering a functionality. So one functionality can consist of like maybe two classes, three classes collaborating. Let's imagine this actually. Let's picture it out. Imagine in Android you're having a view model, and now this view model takes in username and password. And now, before you submit this username and password to anywhere, before you proceed doing any operation with this username and password, which might be authorization, let's say, you want to validate those. And this validation would be like, I don't know, you want to check whether the email is of a proper format or if the password consists of, let's say, 8 characters. So it would be wasteful to make any calls further with these two arguments if they are not matching some sort of criteria. Now, the functionality is you have username and password, you are calling a view model, which is your like your point of entrance in the system. The user types in on a UI, but the UI sends them to view model, which is your thing that you can actually test. And from here, where you're gonna put this validation logic? Is it gonna be in the view model? You could, but if you're approaching or if you're thinking about single responsibility principles, probably you're gonna extract this in separate classes, which are going to be referenced from your view model. But all these, like, you could have email validator, password validator, or maybe one class that does both of them, but that class will be collaborating with the view model. Now we have maybe so at least two functions in two separate classes, but they contribute to the same behavior. They are contributing to the same functionality, and in that sense, a test that penetrates with some arguments like username and password and observing some behavior that we care about, like is like, let's say one behavior would be the email not being valid, another would be the password not being valid, and third one would be both of them are okay. All these three behaviors that we care about, um, they can be considered as unit tests. So a unit is consisting of checking a behavior rather than checking a, like, sort of focusing on a piece of code, block of code. Now, these tests, as I said, they could actually cover multiple physical code blocks. They are called integrated rather than integration, which is mostly common term or terminology in software development, but it's more of like misleading. On the other side, what is an integration test? It would be a test that checks the integration between two systems. Let's imagine we're having an Android application, and this Android application talks to HTTP, it talks to database, and maybe it talks to disk. Now, a test that would check integration between my application and the database, which is external system, would be called or would be considered as an integration test. Hopefully that makes sense. Now that would be the distinction between those two, or at least these are terminologies that I am using inside my courses, my materials, and my community in general, so people know about this. And these are used also in most of the software craftsmanship groups that I am part of, like the London Software Craftsmanship Group, or some in US, and so on and so forth. Okay. Now, next one would be here in the agenda, a topic that was asked from somebody inside the community, which was an approach when doing outside-in test-driven development. How would we start it in Android, considering that there will be some UI involved? Now, as we know, there are two schools of test-driven development, London School and Chicago School of TDD. The London School is a school of test-driven development, which actually is also called mockist, and so outside in or mockist, or there was third, London School of Test-Driven Development. And what is difference between, like, what is important about this school of TDD is that we are starting from an acceptance test, which was the question being asked. And this acceptance test, we use it as a North Star that's going to be driving us towards what to do next, or like what to focus on next. So the acceptance test actually is something that we start with, and then we utilize things like test doubles or mocks. Particularly, the test double that is being used in this test-driven development style is a mock, because it allows us to actually distribute responsibilities into suitable collaborators over time, and we don't have to implement them right away. So you can just distribute this functionality. We can tell or teach the mock, do this for this particular test, and then we can drive the design that way. And once the design is in place, we can do something like we can delete tests, we can do whatever we want. But to drive out the design, this is really essential, or like it is a style of test-driven development that helped me understand a lot and learn a lot about software design and architecture in general. Now, how would you start? The thing is, because the acceptance test is a test that sort of, it is a sociable test, something that we spoke about, and it would cover bigger sort of physical code block. Let's imagine a view model and maybe some of the layers, not maybe, but for sure some of the layers underneath the view model that are maybe coming till the boundary, which is the interface or the place that you actually talk to an external world. So it could be 2 3 layers, let's say, of 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 design that would be considered inside an acceptance test. Now, because the question was it would involve some UI, we cannot really test UI with the JVM tests. Not at least not the way we want. And so what we do is like we want to get as close as possible to the actual UI. So if we are thinking about this, let's imagine piece of functionality. Maybe we can consider, I don't know, authorization comes to my mind, but I don't want always to talk about an authorization. So let's maybe say fetching a list of items. So let's say you are fetching a weather, or maybe let's say you are fetching a feed. Imagine X or Facebook or whatever social network, and you have some feed, and you want to fetch the items of this feed. So what happens is like you open the screen. This screen has some UI, and this UI, as long as like or as soon as we open this screen, we make a call to load some things. In that sense, there will be an entry point where this load will happen. Most of the time, we are detaching the UI from anything else, or we are trying to make the UI as dumb as possible, especially now with unidirectional data flow that comes in Compose. What happens is that the UI simply reflects what's the state. So when we enter to some screen, we are making a call, and then we are observing the state, and based on the state, we render something. Now, this call can come to a public function inside our view model. So we can actually start to tune our tests or to write our acceptance test from that perspective, from that point of view. Now, going back to actually thinking around this, what happens is that we come to the view model, we come to the screen, we call an action to load something, and then we observe state. So what happens is that, thinking from a test perspective, we are going to have some sort of states that are reflecting in the UI. So how about actually making our assertions based on these states, right? So if we want to get a little bit more practical, let's maybe let me share the screen for the people inside the call. So that we can make something practical. Actually, I do have a repository here, and this repository, I'm gonna link it also in the uh, for the live stream. I'm gonna link it below so people can find it. Let's actually write something somewhere, doesn't matter. So let's say maybe I have this timeline module, and it doesn't have any tests. So let's maybe write a test here and like see how would I approach this acceptance test. I'm gonna say um, load timeline test. So this would be JUnit test or Jupyter. Fun load my or load timeline. This being an acceptance test, what I want to focus on is what's going to be the side effect, or what's going to be the output that I care about. When we go back to the reasoning that I started this with, is that there will be some state that will be reflected on the UI. So the UI reflects the state. So in that sense, when I get into the screen, I'm gonna make a call to load this timeline. And while loading, I want to show some sort of progress. So I can say, first, I'm gonna have loading progress, and then I'll get the timeline result or timeline items. So these are the two states that are gonna happen one after another. So maybe I can write an assertion, assert that it should be this one. Observed states is equal to list of, and now, so take a look what I'm doing here. I have nothing. I have no types. I have like only API available for me is the JUnit. I have no types. I have no functions. Equals to is something I can import. Assert that. Let me see empty list so that I can import this. Hmm. Yeah. So observed state. So I have no types, as I said, I have nothing. So basically, by writing this test, I'm forced to introduce some types. I'm forced to introduce some things for this test. And in that sense, when we are talking about outside in TDD, it helps us with design. So it helps us, or it forces us to think about all these things while we are in the red, compared to the Chicago School of TD, where we come up with just a little bit of code, just a little bit of test, just a little bit of code. So like we are building and then refactoring on the go. Here we do a little bit of bigger steps. So what happens here is like now I have to define what my state is going to be. I have no clue, but it could be, let's say, maybe timeline state. I can call it as a timeline state. Now I have to make a decision. Am I gonna have sealed type, which is gonna be timeline state dot loading, or am I gonna have properties inside just a single? So this is a decision that I have to make right now. And because I'm alone now, working, I can decide whatever I feel like. But what's more important is like how easily I can refactor it afterwards. That's actually when the trade-off that you have to make while building the software anyway. So um, I can say here is loading equals true. And then that's going to be the first state that will be delivered. The second state would be timeline state. Now is loading is going to be false. And then I'm going to have timeline items is list of, let's say, post 1, post 2. So am I happy with this writing or not? That's the question that I would ask myself with, because I'm starting from the assertion. So I want to assert that the observed states is a list of timeline state loading and then timeline state containing the items, which is perfect to me, actually. So now I can focus, or I can move on and decide on these other things. So maybe, like, because the post 1 and post 2 are the things that are not compiling, I can create what these post 1 and post 2 are going to be. Well, I can define those. Well, I can define those inside the test, and then I can extract them. So I can say val post 1 is going to be a post, or just post item. Let's say post 1, and post 2 is going to be post item post 2. What is post item? Well, I can create a class for that. In fact, let me make it outside. Data class post item. And then it's going to be post ID. It will have a property like that. Cool. Now this compiles. And next, what's going to be my timeline state? Well, Studio before was allowing me to create classes as well. For some reason, it is no longer allowing me from inside list, or like from these sort of expressions. For Java, I believe it was working much better. Anyway, I can define it as a data class timeline state, and then this state will have these properties: is loading, which is by default going to be false, and then it's gonna have timeline items, which is gonna be, let's say, a list of post item, and by default it's gonna be empty. Now That's going to be my state. Thinking of compose, maybe you wouldn't want to use lists. Maybe you want to use immutable list, but that's out of the scope of this example here. Just bear with me. How would I approach starting from the acceptance test? And now, what are going to be this is my assertion, so which is almost clear. But this assertion will come after an action, and that action would be observed states. Where they're going to be coming from? Well, basically, there will be, as I said, we are getting as close to the UI as possible. And the first point after the UI, because we are detaching our UI from anything else, we are making it as dumb as possible, is a view model or something around a view model. And in that sense, the view model will expose a way for us to observe whether a state flow or something like a state flow, maybe live data you're still using, I don't know. But yeah, you're going to be observing that sort of observable container, and that will allow you to collect the states. So this will come from, I don't know, observe. I don't have the API right now, but I can introduce something like, in fact, maybe I do have, if I make this a run test, it allows me to call, it gives me a coroutine scope, and here I can say collect flow or observe. I did have an extension for that. Let me search for it quickly. Yeah, collect state flow. So I can say, okay, I have to import, sorry. This module where I'm trying to write the test, this timeline, needs to include the projects test utils. Let me think. And then the test utils, we are going to talk about this just in a bit, is a project that allows me to, it contains some testing utilities that are handy. While waiting on a sync, for everybody coming to the live stream, welcome. We're talking about testing on Android currently. I would appreciate if you can like or subscribe to the, or both, to the channel. It helps me. It also helps you by getting notified when we are posting new content. Alrighty. Now I should be able to use this. Oh, come on. And now here I have to define which flow I want to collect and what's going to be the operation that I want to execute. Now, this is more of like out of the scope of how I would start, but basically you need to have an action and then way to collect that side effect. It could be turbine, it could be different library that you're using. So this collect state flow is a utility function that collects a flow, a state flow that I have written myself. But obviously, you can use additional library for this, like Turbine coming from Square is a library that can help us with this. Let me maybe share it here. So Square Turbine. This is the library that I'm talking about, and basically it helps us test flows. So we can collect things that are emitted on a flow, so that we can like basically assert on those. As you can see, the API is pretty robust, pretty cool. Nothing unexpected from these people. These are geniuses that are working there and providing these libraries. So that's great. But yeah, I have written myself a utility for that instead of using the library, which is pretty okay as well. But I need a coroutine scope to be able to collect the things. So here I have to pass a state flow, and then I can maybe call the actual action that will cause these emits. So for example, if I imagine here that I have class timeline view model. And then inside here, I have a state or a timeline state, which is going to be a state flow of timeline state. Like that. Import. And in fact, let me see, can I actually use field here? Mutable state flow. Oh yeah. And that's gonna be timeline state by default. Okay, this is not working. Ah yeah, I'll have to enable that in the build.gradle. So that's not something I'll do right now. So rather I would do timeline state. And then I'll assign this there. Like that. Cool, now that I have this set up here, basically I can collect the states that are gonna be reflecting in my UI, that are gonna define the UI, the current UI that I'm gonna be rendering from my view model. Here I can say that's gonna be my view model dot timeline state. So that's the state that I want to collect. And what operation or what action do I have to make to actually get this happening? So what will cause this to happen? Well, actually, I need to make a call. So if you reflect back to the actual reasoning at the very beginning, I'm going to enter a UI, and this UI causes an action that will reflect with some sort of state. And that action could be an initial load. So here I can say something like view model load timeline, maybe. Now, we can consider pagination, we can consider many, many different things, and we can happily talk about that in a later state. But for now, bear with me. And then finally, it comes to like, what is this view model? Then this view model is going to be a timeline view model. And then what is this function? There is no function for this. So I can say create member function that is basically not implemented for now. Let's move it down like that. And now my acceptance test is pretty much ready. I can extract these two outside. And now if the post item has, like, obviously it's going to have much more properties than just ID. And if you want to still make it easy for us to test, we can create a builder that will help us instantiate post items without supplying all the potential properties that we may have, which is slightly different topic, but it would be something like a post item with ID. Let's say you can have post ID build like that. We can utilize it, but for now, bear with me. And these are going to be private. Right there. Now, if you take a look at this whole thingy, what we ended up with is like we started test driving something. We started from the assertion, and the assertion says, okay, I'm going to have a screen, and this screen will be the UI of the screen will be coming or defined from a state of something. And then we define what that state is going to be. So the two things that we need are the loading state and then finally getting the items being loaded. So we no longer show loading, but we show the items. So those two states are going to be delivered to our UI. And that's what we tried to catch in this assertion. Now, once we had written that and we were happy with it, we started actually extracting things or creating things to make that compile. Part of that were types, and part of that were additional classes like this view model. But we have no implementation, like nothing at all now. And this is just enough for an acceptance test. Now, if I run this test, obviously it's gonna fail First of all, it's going to fail because it involves running or collecting flows, and I need to change the main. Or in fact, no, because this is not a real view model. Okay, so it fails for the right reason. What I wanted to say is completely different. And yeah, so this is perfect acceptance test, or good enough. And now if we start working more in depth, like we can start focusing now, or how the outside in TDD usually works is, we want to introduce some functionality that starts from the timeline view model. So the timeline view model will have to talk to another collaborators to actually get these timeline items. Could be a repository, and we don't know, but we can imagine the types. And in that sense, what we could do is we can write a test that will mock out, it's gonna create a mock for this potential collaborator that we may have, only to define the types. And we can say, okay, give me a list of these types, and then I'm gonna make sure that the state is being delivered properly, or the side effect is being delivered correctly. And I wouldn't care about the implementation of that collaborator just yet. Then when I have that complete that test, I'm gonna go back to my acceptance test, I'm gonna run it again, and it will tell me, okay, now this is implemented, it's cool. And here in this acceptance test, instead of the mock, I'm gonna use the real implementation, which will be not implemented. So for this test, I have a mock that delivers, but for this, I have the real instance that is not implemented. So the acceptance test will say, okay, now this class is not, or this collaborator is not implemented, go ahead, fix it. So I'm gonna go there and start test driving that one. And that's how the whole loop goes, how the whole loop works. And to get more details about it, you can go to my YouTube channel. You can go to the playlists, and here you will find outside in TDD playlist, and you can see the entire process, how everything works when we're talking about Android. And if you are just at the beginning, if you haven't done any test-driven development before, a like this video explains that you can use a sequence diagram, or you can utilize a sequence diagram to actually picture out what you're going to be working on, how you would approach, and then start the coding. And this is really cool technique. It helped me back in the days. It will help you for sure. So go check it out. Um, and that should cover the topic about um, starting with outside in TDD or acceptance test. Cool. One more topic done. What next? Next here, I have how to approach testing modularized setup. So we are gonna still, or again, use this project to show you how I usually do this, which might not be what works for you based on your setup, but it's something that could be easily changed to adapt it to whatever you have. Now, here we have modularized setup. The app module here is the module that binds everything together. It knows about everything, or other modules. And here, basically, this is the only. Okay, we have a question. Go ahead, Eric.
Oh, actually, you're not sharing your screen.
Oh, the screen share stopped. Sorry about that. Is the screen visible now?
Yes, it is.
Perfect. Thank you. So the app module, as I started saying, is the module that binds everything together. It knows about the other modules. And this is the module that contains our interaction tests. So we started with a unit test. We started talking, like after the unit test, we started talking about integrate and integration tests. And on top of those sort of tests, we have some interaction tests, or now we are sort of more going towards the UI, testing the UI, and how we would approach testing in modularized setup. So for example, we most of the time have some shared modules, and we have feature modules. And here in this setup, I have a domain as well. Now, what happens here is, because I decided to split it that way, this might not be the way you split your code, but let me explain the modularization behind this. So we have feature modules where we have, let's say, login, we have sign up. So these two modules are feature modules or part of the presentation layer, and they talk to a domain module, which is here inside the domain sort of domain folder, let's say, and they both utilize the auth. So the authorization is a single module that can do authorization. It can both do login and sign up, and it's part of my domain. And if you take a look here in the build.gradle, I here use the domain auth, and also the sign up does utilize the domain.auth. So both of them, being feature modules, are utilizing same uh, same module from my domain. And in these feature modules, most of the time we have unit tests. Let's take a look into them. That might be checking or testing the state, the particular state being delivered, or like updates on the state. So, for example, you're typing your email, you want to make sure that the email is getting through the state. So maybe you have some sort of you want to establish, let's say, process death restoration. So you're gonna utilize save state handle for that, and you want to make sure the state is working properly. So you may have that kind of tests, or that's what I have here. And then I have the actual login tests, which are sort of checking the functionality or the behavior that I care about. So here I have a view model. Then I set the email and a password. Then I try to log in, and I make sure that the user got logged in terms of the state. So I make sure that the actual state that will be delivered to my UI says this user is logged in. Same if I like, what if I have incorrect password? What if I have incorrect email? What state is being delivered? So basically the assertions are only around the state, and so on and so forth, as you can see. And then here I also have screenshot tests. In this case, I use Paparazzi. You can use any other library, but these tests are ensuring the pixel perfection. So here I have a screenshot that shows how the login should look like, the login page, right? We can have many different screenshot tests, but talking about the size, they are sort of around the same. So in these feature modules, we would have these kind of tests. So unit tests that are checking around the functionality that we care about. In this case, for example, the actual login, and how the state reflects the different login states. And of course, from the UI perspective, we have this pixel perfection. We're going to talk a little bit more about the UI test just in a bit. But that's sort of test that we're going to have here. Then in these feature modules, we have these kind of tests. So here we don't have Android tests. We have just regular tests and main. Same in the domain. In the domain, we have main and test. We don't have Android test because this, like in the domain, we have more like checking around, checks around our domain logic. So we don't have anything Android related. And these tests are basically, it might involve, let's say, some contract tests, whether I think we spoke about contract tests in some of the previous streams, and there is lots of other materials inside the community about contract tests. But basically, these tests are going to ensure proper functioning of our domain. And then going down to or up, as you are projecting this in your head, the app module is the module that binds everything together. And here, in terms of tests, we could have also some unit tests that are basically something that I have here is detect logout signal test. For example, if I can get logged out at any point of time. And um, here I have a functionality that detects if I'm logged out so that I navigate the user back to the login. And it made sense for this test to be here in this module. But what's important about the Android test here is that these tests, compared to the screenshot tests, are checking interactions. So talking about UI tests now, we have these two types. We have screenshot tests and we have interaction tests. The difference being, with interaction tests, we are checking functionality of some sort of uh, part of our application, maybe like a flow. Let's say I'm trying to authorize myself, I successfully log in, I click on something, something happens. Let's imagine. That is an interaction test. So I enter some data and I click around the application and I expect some results to be there. But I cannot guarantee pixel perfection with these tests. So functionally, I can check whether some sort of interaction is working properly, but I couldn't make sure that the button actually is like I can say, can you check if this button is on the screen? But I cannot check if it's on a particular position, if the font is correct, if the color is correct. I mean, there are some limitations. On the flip side, to make sure that everything looks okay, we use the screenshot tests. So they both work together, the same goal. We cannot, I mean, we could go with one or the other one, but part of the things are not going to be tested if we escape one of those. So we need both of them, and they work together basically to help us ensure the UI is looking okay and is behaving okay. And here, again, pardon me, I'm gonna share this repository down in the description of the video. You can find it, and you can. It's an open source repository on GitHub. You can explore it. You can find what we have here. Here, as an example, we have the login test, which actually is based on a robot pattern. And here we do some interaction tests. In particular, what happens when I enter bad email, like bad format of email, and try to submit that. So I should see an error on the screen telling me your email format is not correct. What if I have correct email but incorrect password? Like if the password is not up to the standards. What if I don't know, put wrong credentials? What if I put correct credentials? Those kind of things, I want to make sure whether that interaction is correct, is working properly. So you can explore these tests, you can find out how does that work. But that's sort of kind of test that I would write in my app in the UI tests. So as I said, those interaction tests are inside this module, and inside the feature modules or the domain modules, I'm gonna have tests that are checking on my, like, unit tests that are checking on the, depending on if it's in the feature, whether the state is working properly, or in the domain whether my domain is working properly. Then in the shared, we have some database, we have network, we have UI. So in these modules, like database or network, if we go back to when we spoke about integration versus integrated tests, these are modules where I might have, for example, integration tests, checking whether my integration with the database works okay, whether integration with my network is okay, and so on and so forth. For example, you can imagine, thinking of network, for example, if you're using Retrofit or if you're using Cater, or if you're using GraphQL, both of these frameworks are having a counterpart for testing, which is called mock web server. And then we can actually supply some sort of JSON for a particular test. We can say, we can have one test that says, like, give me this JSON and make sure that this happens for that JSON. Make sure that this happens for that JSON, or for that HTTP code, for example. So those are sort of the tests that we would have in this module. And then we have test utils here. And this test utils is a module that's going to be used only for the tests. So if you take a look at the setup of it, it knows about all the modules. And then by getting all those modules, here we can define different things like different, like let's say builders, in-memory repositories, some test utilities, something like that. And then we can inject this one. This one injects with API. It could be with implementation as well. It depends on like whether you want to access through it or not. And then in the other modules, like let's say in the feature, we are gonna inject the test utils, but only as a test implementation, not as an implementation. So even though it might look like a circular dependency, it's not, because this module depends on, let's say, feature login. Let's take a look. Not feature login, but let's say the shared network or domain out, for example. So it depends on the domain out, but the domain out would depend on the project's test util, but as a test implementation. So in that sense, it doesn't make a circular dependency. And then here inside my domain out, I can utilize whatever is provided from the test utils to do my tests. Alrighty. So that would cover how would we, or how do I usually approach testing in modularized setup. Now it depends again, based on your setup. You may have this, or you can maybe tune this to accommodate in your setup, because your modularization technique might be, let's say, feature, and then inside the feature itself, you're gonna have UI or presentation, then domain, then something that would talk to like the data implementation. You can still tune this sort of setup for that as well. Alrighty, and also part of the agenda was the UI screenshot versus interaction tests, which is something that we covered just a little while ago. And with that, I am running out of topics for the today's call and stream. And let's actually jump into some questions and some answers, if there are any. So, here on the call, we have a bunch of people. If there are any questions, guys, you can write them in the chat, or you can just unmute yourself and ask the questions. And there is a question in the live stream. Are you teaching UT? I'm not sure what UT means. Unit testing. Yes. So basically, I teach everything around testing, and there is lots of materials inside the community. So let me maybe share so you can see what you can find. So if you go to school.com/androiddevs, this is a community that I run myself, and we have around 1.2K members active here. Well, not all of them are active. And this is a community where we have classrooms around Android development, and also part of it is test-driven development, which involves unit testing, UI testing, and so on and so forth. So in that sense, you can join this community if you just go to this link. On the right-hand side, you'll find join or request membership. I'm gonna approve your membership, and you can enjoy some content around testing here, where you are basically part of a community. So you can ask questions, you can make posts from your learnings here. You can send me a DM. I'm available, along other people that you can DM here, and yeah, it's gonna be more collaborative. So you're welcome to join. Hopefully that answers the question. Okay. If there are no other questions, let me see what I got here. Yeah, there is a question from Marco asking, when testing a big view model with a lot of dependencies, does it make sense to split it up, to split up that view model into smaller ones? Yes, it does. So when you have like bigger view model with many dependencies, you can maybe spot a pattern to see like which dependencies are used for which for which functions, for which things. And in that sense, maybe you would see that okay, these dependencies are used for this, these dependencies are used for that. And in that sense, you can split that into two different separate view models, because you may have one view model that sort of does like in the same view model you can have functions that are only doing one thing and another that are doing only another thing. So like you can freely separate that. And in fact, if you are starting from the test, um, when you take a look at a test, when you have hard time testing something, if the test becomes more complex, that's usually a sign that you can um, that tells you that probably your setup is a little bit more complex, so you should start splitting up and simplifying it. Hopefully that answers. And by the way, do not fear having more than one view model. Let's say you're having a screen, and I mean, I've seen articles or people online talking about like you should have one view model for one screen. I don't think that there is a rule, or there is any limitation, or there is any consequences by having more than one view model for a view. So in that sense, if I have, let's say, one screen that, I mean, just thinking out loud now here, maybe this example is not the best, but let's imagine you have a screen that has list of posts, and then you have a profile on top, just like Twitter, for example. You have your profile and then some posts below. I see zero issues having one view model that deals with your profile and another one that deals with with your timeline items. Another example would be something that I've been working on recently is like I have a screen of something like email items, and then there is a search on top. And then this search was working with some APIs that were completely relevant to the actual list of items, list of emails. So I had two view models injected in the same screen. One was dealing with the search, another one was dealing with the actual content of the screen. So yeah, that's something that I would consider doing. Hopefully that answers the question. Alrighty. Um, anyway, if there are any further questions, you are all welcome to join the community. Send me a DM. Happy to answer, or like just drop the questions below in the stream in the comments. I'll also try to answer them, maybe in the following stream or differently by typing. And yeah, with this, I would like to close the stream for today, and this co-working session. Hopefully it was useful. And thank you everybody for participating, for coming to the call, for staying this long. And also for the people on YouTube, thank you so much. And I would really appreciate if you can like or subscribe or both on the channel. That would mean a lot to me, and it would help also you. Whenever we are posting something, you're going to get a notification for that, as you already know. Cool. Thank you once again. And yeah, seeing you next week. Cheers.
Cheers.